Can a tropical cyclone in the China region affect the summer monsoon in India? Sounds strange, right? But the atmospheric telecommunications make this possible. The telecommunications actually affects the climate kilometers away, that is in India. In our next topic, we are going to discuss the recurrence of floods in Assam region created by rivers Brahmaputra and Barak. Welcome to this week's Geography Current Affairs Analysis. My name is Arjun. Let's begin. So, we will discuss the first topic, that is the Typhoon Dolphin. So, recently the Typhoon Dolphin made landfall in the Zhejiang region on August 9th. So, it produced very intense rainfall and flooding in the Chinese region, and simultaneously the parts of India are adversely affected. Our monsoon faced breaks and dry spells. So, this sequence is an example of atmospheric teleconnections. An atmospheric event that is actually thousands of kilometers away can influence the atmosphere of India or any other region which is far away. So, in this context, India is adversely affected and obviously China is also adversely affected. This picture actually shows the teleconnection. So, when the Typhoon Dolphin actually hits the China region, it is experiencing very heavy intense rainfall in the region, and obviously it causes floods. At the same time, India, which is actually thousands of kilometers away, is facing disruptions in the monsoon pattern. So, we are facing dry spells. Okay. So, we will discuss typhoon. So, typhoon is basically a powerful rotating tropical cyclone, and it forms generally over warm waters of tropical region, that is in the 5 degree to 30 degree latitude, maybe in northern hemisphere or maybe in southern hemisphere. So, this is the region where tropical cyclones generally form, and we have different names for different tropical cyclones in affected regions. For example, Indian Ocean, they are called tropical cyclone itself, and in South China Sea and Western Pacific region, it is called typhoons. So, basically near Japan, China and Philippines. So, this region, it is called typhoons, and then it is known as hurricanes near North America, Caribbeans and Central America. And in the Western Australian coast, it is known as Willies. Okay, Willies. So, these are the different regional names of tropical cyclones. And typhoons, obviously, as a form of tropical cyclone, it actually have sustained speeds of at least 74 miles per hour or 119 kilometers per hour. So, more than the speed, tropical cyclones in the region are called typhoon. Okay, in the South China Sea region, in the region of Japan, China or Philippines. So, we will see the formation of tropical cyclones, the prerequisites and the evolution, how it intensifies and forms the proper tropical cyclone. So, primarily we will see the key ingredients or prerequisite for the formation of tropical cyclone. The first important thing is the warm sea surface, that is 26.5 degree and above. So, this warm sea surface creates a low pressure. So, a low pressure is created, and definitely whenever a low pressure is created, it attracts wind from all the regions. So, whenever a low pressure is created, it attracts winds from all the surrounding regions to the low. So, this one attracts winds. Next is the high atmospheric moisture content. Since it is a warm ocean surface, we will have enormous amounts of moisture content. Next comes low vertical wind shear. That means the wind speed or difference of wind speed between lower levels of atmosphere, wind speed difference between surface and higher layers. So when the wind speed is higher, there will be destruction of the low pressure and hence cyclone formation may not happen. And next important thing is the Coriolis effect, which actually creates the rotation. So cyclones generally form beyond 5° north and south. So 0 to 5 or between 5° north and 5° south, there is absolutely no formation of cyclone because of the absence of Coriolis force. Beyond that, we experience Coriolis force and hence cyclone formation is possible in this region. So important factors responsible are the sea surface temperature having 26.5° or above, which creates the low pressure, and then the Coriolis force, and next important thing is the supply of moisture and obviously the low vertical wind shear. So when all these factors are in favor, it will start formation of a tropical depression. So a tropical depression is formed. So it's a low pressure region. Depression generally means a low pressure region. So this low pressure region eventually develops into a tropical storm, where because of the Coriolis force, the winds will start spiraling. So the winds will start spiraling because of the Coriolis force. So this is the low pressure created and winds are coming, okay, winds are coming, and in our case it is in the northern hemisphere, and because of the Coriolis force, winds are getting deflected towards the right, okay, winds are getting deflected towards the right, and hence in this region we will have a anti-clockwise rotation. So anti-clockwise rotation is created in northern hemisphere, right? So anti-clockwise rotation is created, and here the center of the cyclone is called eye and surrounding region is called eye wall, eye and eye walls. Along the eye wall, gradually it will start condensation. So this is the eye wall and this is the eye region, okay, this is the eye, this is the eye of the cyclone, okay, and this is the eye wall. So eye wall region will have condensation whereby clouds are formed. So cloud formation starts along the eye wall. So this condensation actually releases the latent heat of condensation into the center of the cyclone. So this region is getting more and more heat energy. The center portion is getting more and more heat energy. So more heat energy means the existing low pressure at the center, the existing low is intensified. So the existing low is intensified and height of the spiraling increases. So in this stage, because of the latent heat supplied by condensation, the low pressure is intensified and hence the height of the circulation increases. As the low pressure is intensified, more and more winds are coming from all the sides, okay. So more and more winds are coming from all the sides. That means more moisture is getting supplied, and more moisture means more condensation heat is supplied. So the intensification increases. So it's a kind of like self-perpetuating cycle. It's a self-perpetuating cycle. So as the latent heat is released, more and more low pressure is created at the center and more winds are getting attracted. So these winds will supply more condensation energy and hence the height of the cyclone keeps on increasing. So more intense cyclone is formed in this stage, hence the mature cyclones are formed. So this is how cyclone is formed. So I'll explain once again. So we'll start with the important conditions, that is the pre-existing low pressure 26 and 5° or above temperature and Coriolis force. So at the starting stage, the low pressure attracts wind from all the directions and Coriolis force spiral them in anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. So once we form the spiraling circulation, along the eye wall we will have condensation and formation of clouds. So when condensation happens, it will release condensation energy, the latent heat of condensation. So that heat intensify the low pressure of the cyclone. So more intensified low pressure at the center means more and more winds are attracted from all the sides. So this intensifies and increases the height of the cyclonic circulation. So this process continues unless there is supply of moisture. So unless the cycle makes landfall, the process continues. So whenever the cyclone is making landfall, the supply of moisture is cut off and hence the cyclone actually dissipates. So this is the process. And then in this context, the typhoon dolphin is actually a very strong convection, and hence the latent heat release was so high and it actually alters the upper air circulation also. So this upper air circulation changes affects the wind patterns globally. So this influences wind patterns globally, wind patterns, jet streams, etc. globally. So this affects Indian monsoon. Okay, so this affects Indian monsoon, and also it influences the location of Indian monsoonal trough, which is the low pressure along the Indian plains, which attracts the monsoon winds. So this affects not just the global wind patterns, but also affects monsoonal troughs position, and obviously it affects the favorable cyclonic disturbances that formed in the Bay of Bengal region. So this actually affects as a sponge. The article actually uses the word sponge. The news articles uses the word sponge, where the cyclone typhoon is actually sucking away moisture, not sucking away actually, but literally it's as a analogy they are using. Okay, so it is actually reducing the cyclonic disturbances in the Bay of Bengal region, and hence it also reduces the impact of monsoon or the availability of monsoon in our region. So all of this causes monsoon breaks and dry spells in the region. So this is how it is actually creating the upper level circulations are affected, and obviously the position of monsoon trough is also affected, and the cyclonic disturbance formation that create rainfall in the Bay of Bengal is also affected. So overall Indian monsoon faces dry spells. So this is how it influences Indian monsoon, and apart from this there are so many other factors also which affects the Indian monsoon. So we have important land factors, ocean factors, and atmospheric circulation patterns which affect Indian monsoon. So the monsoon is actually a result of all these factors, but the adversity or adverse impact of some factors can reduce the monsoon. Okay, so just go through the factors given here, and if you want any of the factors to be discussed separately, please let me know in the comments. I'll discuss any of the factors, or even the monsoon topic itself I'll discuss if you request. Okay, so we'll move on to the second topic, that is the Assam floods of 2026. So currently Assam is facing a very severe flood which actually affected or has taken away the life of 30 people. At least 30 people have lost their life, and more than 8 lakh people are currently affected. The numbers may even go higher. Okay, and this is one of the most severe flood episodes in last 60 years. Okay, in last 60 years it is one of the most severe flood events, and also this time this events actually reported flooding of relatively less flood prone areas of Assam, that is the upper Assam or the eastern Assam region. So earlier the western Assam is actually already flood prone and we are having frequent floods in those regions, but currently the floods are actually shifting towards the eastern region also, which was considered relatively less flood prone. So district like Jorhat, Shivsagar and Cheraideo etc. are actually affected because of the current floods. So this actually raises concerns over the changing spatial patterns of the floods. So we cannot have a proper plan. Okay, this region is going to be affected. So that is now impossible because of the climate change and the convergence of effects. Now we will see why Assam region is flood prone. So Assam is actually flood prone because of two important major rivers, that is the river Brahmaputra and river Barak. So these are the important rivers that cause the most recurrent floods in Assam, and hence approximately 40% area of Assam is flood prone. So remember, approximately 40% of the area is flood prone. And then we have so many tributaries of this rivers, approximately more than 50 plus tributaries are there. So all of them actually causes flooding in the region. And then these are actually Himalayan rivers, and Himalayan rivers are generally having very high erosional activity, high erosion. So high erosion causes extremely high sediment loads in the Himalayan rivers. So Brahmaputra is actually notorious for extremely high river sediment load and formation of braided channels. So it forms braided channels which are actually network of river channels created because of the sedimentation. So sedimentation obstructs the flow and creates so many numerous channels, and all of them cause flooding and havoc in the region. So this is one important aspect. And then we have very heavy southwest monsoon rainfall in the Assam region because of the funneling effect of the mountain regions. So the Bay of Bengal branch of monsoon is actually facing a funneling effect, and hence it is concentrated in the region, causing very heavy intense rainfall in the region. And then we have rapid runoffs from adjoining states like Arunachal Pradesh, Nagaland, Meghalaya, etc. into Assam. So because of the slopes, the water will be flowing very faster into the regions of Assam. And apart from this, there are some like river properties also affecting the flooding. For example, like erosion, then embankment breaches, etc. affects the region. Okay, so these are the important reasons of flood in the Assam region. Now we will see what went wrong in 2026 or current floods. So what are the changing patterns of floods? So earlier when we see this part, this reach or the western reaches of Assam or lower reaches of Brahmaputra was actually more prone to the floods. But now the flooding has changed to the upper reaches of Brahmaputra. So this is the current changes. Okay, and these changes are actually caused because of the upper Assam inundations. That is, this region is now receiving more rainfall because of some changes, and because of that the tributaries of Brahmaputra in the region is having more water. So the rivers actually breach the channels and causes floods in the region. So this is the new risk area and this is the previous risk area, and this is actually created because of some changes which is actually direct climate change impacts and also obviously some specific issues in the region. Okay, so we'll see all of the reasons. So there are many human factors that amplify the floods in the region. For example, like very heavy deforestation is actually happening in the region. So whenever there is deforestation, it actually reduces the infiltration of water. So whenever river water is infiltrating, it will recharge the ground and runoff decreases generally. But here infiltration is reducing and runoff is increasing. So this will lead to more erosion and hence more sedimentation is also caused. And next important one is mining and excavation in the region. So whenever we are mining, we'll destabilize the slopes, right? So slopes are destabilized, and I have discussed how slopes are destabilized in previous chapters, previous recordings. You can watch that. And whenever slopes are actually destabilized, it will create more sedimentation in the rivers. So more sedimentation in the river will create reduced channel capacity. So, the depth of channel decreases, that means it cannot hold water as much as it was holding earlier. So, what will happen? Rivers will breach the channel, it will swell beyond the channels. So, that is why we have floods in the region. Next important reason which amplifies the problem is the floodplain encroachment. So, people are actually setting the infrastructure in the floodplain regions which were actually the natural storage of water. Floodplains actually act as a sponge which absorb the abundant water during the rainfall seasons and then release the water in later seasons, summer seasons. But when we have encroached the region, what happens? That sponge effect is no more there. So, it actually affects the floods in the region and frequency of floods in the region. Next is the wetland loss or BEAL loss. So, the wetlands of the Assam region are particularly known as BEALs. So, Deepor BEALs is a famous example which is a Ramsar site, okay, Deepor BEAL. Similarly, there are so many earlier floodplains or earlier river channels which are actually called as BEALs or wetlands in the region. So, this one is also being encroached by people. So, hence it reduces the natural flood buffering. So, floods are more frequent because of the loss of floodplains, and same way the wetlands and BEALs in the region. Then there is actually the confinement risk of embankments. So, whenever river channel is actually having low depth, will create embankments along the region so that river water is actually stored within the channels. So, what if the embankment fails? So, the failing of embankment also causes flooding. So, these are the important reasons in the region, and we will discuss why India's flood management actually struggles. Our flood management model is actually primarily based on embankment type or embankment centric approach. So, we will create embankment so that rivers won't breach the channels, but there are chances that they may fail. So, this is one important reason. Next important reason is the floodplain zoning is poor in our region. So, proper zoning is there, that means we can actually restrict certain activities in the more severe regions or more hazard prone regions. So, that floodplain zoning as well as management is very poor in India. So, it also actually compounds the effect. So, it creates a cascading effect. Then there is weak maintenance of forecasting or that kind of stations, and there is inadequate reservoir coordination between different states. Most of the states, most of the rivers are actually transboundary rivers or maybe interstate rivers, but we have very poor coordination between states or maybe between other upper riparian countries. For example, in case of Brahmaputra with China, Tibet region. So, this is a very important negative of our flood management. Then weak last mile warning is their execution. The terrain is very difficult. So, last mile warning and execution makes it very difficult. And then we are excessively dependent on post disaster relief type of flood management. So, we are actually not focusing on the forecasting and mitigation part. So, that is missing in our context. And we can say a core mismatch is there, that rivers actually operate at basin level and governance generally operate at administrative scales. That means within a state we will have some coordination activities, within other states we will have different types of coordination activities. There is no interstate coordination in the case of floods. So, that is also a very unfortunate scenario. Then how can we go ahead? So, we can actually have integrated river basin managements in our country. So, the states, riparian states can come together and have a proper management plan and have a basin level planning. So, for example, if which all states are involved, they can come together and they can have a basin level planning. And then there should be sediment management. So whenever sedimentation is there, for example, the schemes like room for river. So the sediment can be cleared in a scientific manner so that river will flow its proper natural flow. So that is an important aspect. Then coordinated reservoir operation should be there. So for example, this is specifically in the case of Brahmaputra, larger dams are coming in the upper riparian countries. So we need to have proper reservoir operation coordination between India and China, right? So it is one important aspect. Then we can have natural based solutions, restoring of wetlands, and then protecting of floodplain, reclamation of floodplains, and then riparian afforestation can be there, and catchment treatment, etc. can be used so that infiltration will be more. Then we can use technology, satellite based mapping, etc., AI based forecasting, and real time warnings, impact based early warnings, etc. can be used. So these are the important aspect that can be done, right? And now in case of Assam, what all things can be done specifically? So primarily we need to have resilient infrastructure in the region, and also we need to have community resilience, because we are living in an age of climate change. So we cannot avoid such floods or such adverse events, but we need to live with such events, right? We need to mitigate the adverse impacts. So that is our aspect. So we need to have resilient infrastructure and also community resilience. So these are two important aspects, not just for Assam but for entire country, right? So this need to be constructed. So raised roads and then bridges, settlements, etc. can be created. So elevated ground floor can be created. For example, in case of Assam, there is something called Chang houses. Chang is a type of elevated house. So the people will be staying in the first floor in the Chang type of houses. It's a traditional tribal type of houses. So these kind of traditional knowledge can actually be used in resilience and also community resilience. So this can be used in the aspect. So these are the important things that can be done in the region. So that's all from my side. Thank you.
Amrita IAS Academy.